As cloud computing becomes ubiquitous, we have to evolve the way data centers are architected in order to increase compute capacity and deliver faster data processing. We need to integrate accelerators that excel at processing specific workloads, smart NICs that perform computation on data in motion, and computational storage to process data at rest. These devices already connect over PCI Express, but to better optimize how they work together in heterogeneous system architectures, they need Compute Express Link. Developed through a consortium of companies representing all major computer architectures, CXL is an open interconnect standard that increases memory capacity and bandwidth and enables lower latencies. It leverages the PCIe Express 5.0 physical layer infrastructure to create a common memory space across the host and all devices. Most importantly, CXL is a cache-coherent standard, which ensures that the host processor and CXL devices see the same data when they need to access it. The CPU host is primarily responsible for coherency management, allowing for both the CPU and device to share resources for higher performance and decrease software stack complexity. This leads to reduced device costs and overhead traditionally associated with coherency across an I/O link. The CXL 1.1 specification defines 3 new protocols. The CXL.io protocol is very similar to PCIe 5.0, with some enhancements. It is used for initialization, link-up, device discovery and enumeration, and register access. The CXL.cache protocol defines interactions between a host and device, allowing attached CXL devices to efficiently cache host memory with extremely low latency using a request and response approach. The CXL.mem protocol provides a host processor with access to device-attached memory using load and store commands. Different combinations of these protocols result in 3 initial CXL usage models. Type 1 devices coherently access host memory. This would be, for example, an accelerator with a coherent cache, which wants to share access to host memory. Usage for Type 1 devices includes PGAS NIC and NIC atomics. Type 2 devices are able to coherently access host memory and allow the host to access device memory. For example, this would be an accelerator with attached memory and optional coherent cache. Usage for Type 2 devices includes GPU and dense computation. And finally, Type 3 devices allow a host to access and manage attached device memory. This would be memory buffers or expanders that allow the host expanded access to additional memory. Usages for Type 3 include increased memory bandwidth and capacity expansion, as well as persistent memory. To learn more about the CXL 1.1 specification and how CXL 2.0 provides additional features, please visit computeexpresslink.org.